So we are looking at applications of laws of motion, and we are starting with how to apply the laws of motion on pulleys. So here we've been given a pulley system. You've connected one block is on top of a horizontal top of a building, and then you have got another one which is suspended, and these two are connected by a rope. Now let's say we've been asked to calculate the acceleration of this system. Apart from acceleration, we've been also asked to calculate the tension in the rope. Remember we said last time when we were talking about forces, we said tension is simply the force that is found in a rope. So I want to find what force is in this rope. So the question is, how are we able to calculate those? So to be able to do the calculation on this, we need to understand or look at the forces which are acting on this object alone, and we're also going to look at the forces which are acting on this object alone. So looking at this mass, the 8 kg mass, you see that it can only move either up or down. So for this one, let me call the first one here as m1, mass 1, and let me call this as mass 2. So meaning that for mass 2, it cannot move in the x direction. So you can only talk about the net force in the y direction because it can only move up and down. And how can you find the net force on this object? Remember, how do you find net force? Net force is given by the force that will be making something move minus a force that will be making something not to move. So this object, because it is suspended, it is free to move, there will be a weight force that is going to be pulling it. So its weight is going to be pulling it down. And weight is given by mass times gravity. Okay. Now, what force is going to be preventing it from moving? As you can see on top, it is connected to this object. So, this object is going to be offering resistance to the movement of this one. And that is going to be through the force that is going to be found in this rope, and that is called the tension force. So therefore, to look at the net force of this object is going to be given by mg, that is the force going down. I will not say m because m is not force, that's mass. I'm saying mg because that's a weight, that's a force. And then you are going to remove the tension because that's a force going in the opposite direction. So that's how you find net force for this object here. And according to Newton's second law of motion, how do you find net force? Net force is given by mass multiplied by acceleration. So this is going to be equal to mass times gravity minus tension. And remember, this is not just mass but mass 2. So let's put 2 there. I'm going to take this term this side. I'm going to take tension the other side. So this is going to give us tension being equal to mass 2g. And then if this term goes this side, it's going to become negative mass 2a. So we can replace values there. Mass 2, we know that's 8 kg. Make sure that it is in kgs. G is 9.8 minus mass 2 again, that is 8. We don't know the acceleration. So tension is going to give us, if we multiply 8 by 9.8, that will give us 78.4. Then minus 8a. So we can't go further than this. We will call this as the first equation. And then after that, we are now going to look at this mass. Now, because this mass is seated on a horizontal plane like that, it cannot go up or down. Like, what forces are going to make it to go up or down? There are no such forces. So for this one, movement is only in the x direction. So for this object, which is here, going to look at the net force, not in the y direction, but in the x direction. And that will be given by the forward force. What force is going to make it move in this direction? You see, if this object is going to be moving down, it means that this one is going to be moving forward. If this object was moving up, it means that this one would have been moving in that direction. So don't confuse those. If I say this one is going to be moving down, then I need to say that this is moving forward. If I say this one is going to be moving in this direction, then this other one should be moving up. So since I said that the 8 kg mass is moving down, then the 5 kg mass is going to be moving forward. So to look at the net force, we're going to say force pulling it in the direction of motion. So you see there will be a force in this rope, and that is called the tension. So the tension which is obstructing motion in the first in M2 is the same tension that is pulling this object in this direction. So you see that the same tension is acting as a friction in this object because it is going down. And the same tension is acting as what? As a forward force in the other object. So net force is going to be equal to tension. Do we have any force going in the opposite direction? For this question, we haven't been told if there is friction. So we're going to take that this is non-friction. So meaning that the net force is going to only be equal to tension. You don't have any other force in the opposite direction. And you know that net force is given by mass multiplied by acceleration. And that is going to be equal to tension. So the tension here going up is the same as tension here going forward. Why? Because this is the same rope. Now we are going to look, of course this is M1. So M1, that is 5. You don't know the acceleration, should be equal to tension. Again, we don't know A, we don't know T. So this will be the second equation. So the next now will be to solve these two equations simultaneously. So you can see that this is tension, also this is tension. So just get this term and this term and equate them. So we're going to say 5A is going to be equal to 78.4 minus 8A. I'm going to get this 8A, take it the other side. That is going to be 5A plus 8A being equal to 78.4. So 5A plus 8A, that is 13A, and that is equal to 78.4. So to remain with the acceleration is going to be 78.4 divided by 13. And that is going to give it about 6.03. This is acceleration is given by in meters per second squared. This is the acceleration of the system. How do you find the tension? To find the tension for the second part, so we've answered part A, the acceleration. Now the tension in the rope, can either use this equation or use this equation depending on what you want. Let's use the second one. Tension is given by 5 multiplied by A. So this is going to be 5, the acceleration, that is 6.03. Let's see what we get. So that is going to give us about 30.15. Remember, tension is a force. This is in Newton. That is the SI unit for force, Newtons. So this is how this question is going to be worked out. Is anyone left out? Are we good with the working? It's the only one we can use for here. Yeah. Okay. So in the same question, if we've been given friction, so let's say they said the coefficient of kinetic friction in this question, let's say they said is 0.12. So what would be the acceleration and what would be the tension? So given such a case, for this object, again, it is only moving in the y direction. So the net force in the y direction is going to be equal to the force going down, that is mg, minus the force taking it up, that is the tension. And net force is still given by mass multiplied by acceleration. And that is going to be equal to mg minus tension. So since we are talking about this one which is moving down, this is m2, this is also m2. So the mass is 8. We don't know the acceleration. And that will be equal to the mass still is 8 multiplied by g, which is 9.8. And then minus tension. So again, if we multiply 8 by 9.8, it will still give us the same answer as we had, 78.4. So this will be 8A is equal to 78.4 minus tension. So for me to remain with tension, I'm going to take t the other side. It becomes positive. and then that will be 78.4. Then I'll take the 8a, the other side becomes negative 8a. This is going to be equation 1. Now when you look at this object which is here, because it is on this surface and you've been also given a coefficient of kinetic friction, meaning that the surface is going to have what? Friction. If you can see, for this one I haven't used any friction because it is not attached to the surface. It is not attached to this surface here. That is why I have not used any friction. But for this object here is going to have a friction which is going to be pulling it in this direction, and that is what? Kinetic friction, because it will be moving. So for this one, I'm going to say net force in the x, because it is moving in the x direction, is going to be equal to the forward force, that is the tension, minus the backward force, that is kinetic friction. Now net force is given by what? Mass multiplied by acceleration, and that will be equal to tension minus kinetic friction. Now how do you find kinetic friction? Last time we had talked about this. Kinetic friction is given by coefficient of kinetic friction multiplied by normal force. For an object that is on a level surface like this one, the normal force, that is the force going up, is equal to the weight force. So where there is normal force, we are going to equate to the weight force. And you know that weight force is given by mass times gravity. So this is going to be mu kmg. That will be the formula. So again, I'm going to replace mass. Remember, for here we are talking about mass 1. So this will be m1, also be m1. So m1 here is 5, multiplied by the acceleration is going to be equal to tension minus coefficient of kinetic friction 0.12. Mass 1, that's 5. And then g, that's 9.8. So this will give us 5a being equal to tension minus, so we'll multiply 0.12 multiplied by 5 multiplied by 9.8. That is going to give us 5.88. So I want to remain with tension, so I'm going to take this 5 the other side. So that will give us 5a, it becomes positive 5.88. And this is going to be equal to tension. So this will be the second equation. So you can see here we've got tension is equal to, also here we've got tension is equal to. So what we are going to do is we are just going to equate these two parts. We're going to equate this part with this part. We're going to say 78.4 minus 8a. So that is minus 8a. That is going to be equal to what? The other part, which is 5a plus 5.88. So at this point we just take like terms to the same side. So I'm going to take this negative 8a this side. I'm going to take this 5.88 this side. So that will be 78.4 minus 5.88. And that is going to be equal to 5a. The 8 becomes positive 8a. So we can subtract that. 78.4 minus 5.88, that is 72.52. If we add 5 plus 8, it is going to give us 13a. So to remain with a, the acceleration is going to be 72.58 divided by 13. That is going to give 5.58 meters per second squared. That's acceleration. To find the tension, we can use either this equation here or we can use this equation here whatsoever. So let's use this one. Tension is equal to 78.4 minus 8a. But where there is a, we're going to put 5.58. Let's see what we get as the tension. 78.4 minus 8 multiplied by 5.58. So the tension is now going to be 3.76 newtons. So that is how you are able to work out this question. This is how you apply the laws of motion on pulleys.